All right, so this is the actual screencast on the binomial theorem. So we're going to start off by adding to the next 3 rows of Pascal's triangle. So we already have the pattern of the 1, 1, 1, 1, 2, 2, 1. So remember the outsides are 1, and then you add the 2 previous terms. So 1 plus 2 is 3, 2 plus 1 is 3, and then 1. Then we have 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1. And also notice they're symmetric. So once you get to the middle, you can just repeat the pattern also. 1, 5, 10, and then I'm repeating the pattern, 10, 5, 1. Okay. All right, so that's good enough. We can add more to it if we need it for later, but then also this is for when n is equal to 0. This is n is equal to 1, n equals 2, n equals 3, n equals 4, and n equals 5. Okay, so it says using Pascal's triangle and the patterns that we learned yesterday or in the binomial theorem exploration that we did, expand each of the following. So what I want to remind you of is that x plus 2 quantity cubed is x plus 2 times x plus 2 times x plus 2, which we could do by hand. Same thing with all of these, but like it starts to get to be a pain when you have to do this multiplied by itself 5 times, and there's so much room for error. So we can use the binomial theorem to expand that. Okay, so what you're going to do is you're going to look at what n is. This is in the form a plus, that looks like a c right there, parentheses, a plus b to the nth power. So this is where n is equal to 3. So you go to the 3rd row of Pascal's triangle. You can see that the coefficients are going to be 1, 3, 3, 1. So we're going to go 1, leave some space, 3, 3, 1. And since this is going to be an expression, I'm putting plus signs throughout, and then it'll take care of itself if it turns to a negative. Like in this one right here, we'll have negatives. That will take care of it. Okay, so, and then the pattern was, remember that the x's start off with that n exponent, so x cubed, right? Or the first term, I should say, not the x's, because it doesn't have to be an x. So the first term starts off by it being cubed, and then it decreases by 1. So that's x cubed, this is x squared, this is x to the first power, and then this is x to the 0 power, which we don't need, so I'm just not going to write it. And then your second term, which is a positive 2, starts off to the 0 power and increases. So this is 2 to the 0 power, which I technically don't need, 2 to the first power, 2 to the second power, and 2 to the third power. And now I can just clean this up. Calculator is allowed throughout this chapter, so I'm going to get my calculator out off to the side to do anything that is, you know, too strenuous for my brain, but this should be fine. So remember, 2 to the 0 power is 1, so I don't even need that there. So I have x cubed, and then I have 3 times 2, which is plus 6x squared. 2 squared is 4 times 3, which is 12x, and then 2 cubed is 8. So there is it expanded. It might not seem at first like it's faster than doing x plus 2 times x plus 2 times x plus 2, but it is once you get like into the pattern of it. All right, let's go ahead and do another one. So here n is 4, so we're going to use the 4th row of Pascal's triangle. So not the 4th row, the n equals 4, which is technically the 5th row. Not technically, it is the 5th row. That's 1, 4, 6, 4, 1. So we're going to do 1, 4, 6, 4, what the heck, where did that come from? 1. Okay, so my first term is 2x, so this is going to be 2x to the 4th. Then I have 2x cubed, 2x squared, 2x to the 1st, and then 2x to the 0 I don't need. If you want to write it and then get rid of it, like say that's 1, you can. My second term is negative 3, so this is going to be negative 3 to the 0 power, which I technically don't need because it's equal to 1. Negative 3 to the 1st, negative 3 to the 2nd, negative 3 to the 3rd, and negative 3 to the 4th power. And now we got to clean this up. All right, so this is 1, and then we have 2x to the fourth power. So that's 2x times 2x 4 times. So don't forget to bring your 2 to the fourth power also. So that's 16x to the fourth. Then I have 2 cubed, which is 8. This is 8x cubed times 4 times negative 3. So 8 times 4 is 32. 32 times negative 3 is negative 96. So negative 96x cubed. Once again, you can use a calculator to make sure you're not making mistakes. 2x quantity squared is 4x squared, right? So 4x squared times 6 is 24x squared. And then this is 9. 24 times 9, I don't want to make a mistake here. I'll do it off to the side. Is 216. So we have plus 216. Did I do that right? 9 times 6 times 4. 216. So we have plus 216x squared. And then we have 4 times 2 to the x times 27. So 27 times 4 times 2. 27 times 4 times 2 is 216 also. So plus 216x. And then this is 1 times 1 times 81. Nope, I messed up my sign there. That is a negative 216 because it's a negative 27. I forgot to put down the negative 27. And negative 3 to the fourth is 81, positive 81. So there is my binomial expansion. Let me just check to make sure I did that right. That's negative 3 squared, which is 9. 2 squared is 4 is 36. 36 times 6, I'm doing it like 3 different ways to make sure I don't mess it up, is 216. The 216 and 216 just felt weird, but I'm okay. Okay. All right, to then check my exponents, 4, 3, 2, 1, 0. Good, I feel good about that too. Okay, let's keep moving on here and doing this. So, and you can, so I've been doing this all my first terms, or sorry, all my coefficients, all my first terms, all my second terms. You can do one term at a time. Like you can do, this is a 1. My first term is going to be to the 5th power, and my second term is going to be to the 0 power. Like you can do that if you want. But it's up to you. So I'll try doing it this way. This is my n equals 5, so I'm using 1, 5, 10, 10, 5, 1. I got it. All right, so the next one is plus 5. This would give me x to the 4th power because I'm down 1 from that. Negative 2y to the 1st power because I'm up 1 from that. Then I have 1, 5, 10, 10, 5, right? 1, 5, 10, 10, yes. So 10 is next, x cubed would be next, negative 2y to the 2nd would be next. I'm going up 1. Also, if you're not noticing, these two, 5 and 0, always add to that number right there. 4 and 1, add to 5. 3 and 2, add to 5. So once you have 1, you can get the other one pretty easily. Plus 10 times this is going to be x squared because it's going down 1, and then this would be negative 2y cubed. Plus 5. X to the 1st, negative 2y to the 4th. I'm running out of room here, so let me move this over. There we go. And then we have plus 1, x to the 0, which I don't need to write, negative 2y to the 5th power. Okay, now let's expand this. I'm going to first cross off anything that's 1. That's 1, and that's 1. And maybe not write it down in the future. Who knows? All right, so this is x to the 5th, and then I have 5 times x to the 4th times negative 2y to the 1st. That's negative 10 x squared, or sorry, negative 10 x to the 4th, y to the 1st, right? All right, and then the next one, I have 10 times x cubed times negative 2y squared. So negative 2y squared is 4y squared. So that's positive 40x cubed y squared. And the next one here, I have negative 2y cubed is negative 8y cubed. So that's negative 80x squared y cubed. Negative 2y to the 4th is 16y to the 4th. 16 times 5 is also 80. So positive 80xy cubed. That doesn't add to 5, so x y to the 4th. No, what did I make a mistake? X squared. This was x cubed. This was y squared. What did I do? 5, I'm on the wrong one. 5, 4, 3, 2. I was right the first time. 2, 3. I'm at 1 here. 1, 4. There we go. All right, last one is negative 2y to the 5th power. So that is minus 32y to the 5th. 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. Notice I'm checking my exponents to make sure I didn't make a mistake. All right, so there is my answer to that binomial expansion. All right, last one. This is a 4th power. So if I go to n equals 4, that's 1, 4, 6, 4, 1. So I'm going to do it the way I did it before. I feel like I was making less mistakes. I think I was getting caught up in my own work here. All right, so x squared is going to be my first one. Oops, I wrote x squared wrong. X squared to the 4th power. X squared, no, I did it again. X squared to the 3rd power. X squared to the 2nd power. X squared to the 1st power, and x squared to the 0 power, which I don't need. All right, and then for my second term, which is a 4, I have 4 to the 0 power, 4 to the 1st power, 4 to the 2nd power, 4 to the 3rd power, and 4 to the 4th power. Voila. Okay, cleaning this up. This is x to the 8th, right? Power to power, multiply your exponents. And then that is 4 times 4, which is 16. X to the 6th, power to a power, multiply your exponents. That is 16 times 6, which is 96. X to the 4th. 64 times 4, which is 64, 122, 56. X to the 2nd power. And then lastly, 4 to the 4th power, 256. No, what did I miss? No, that's right. Okay. I thought I was missing my x term, but these are evens. Okay. All right, next it's going to ask us just to find a specific term. So I need to find the 3rd term of a minus 3b to the 6th power. So I need to know when n is equal to 6, what my coefficients look like. So I didn't do that yet. So n equals 6. Let me move that over. All right, so that's 1, 6, 15, 20, 15, 6, 1. Okay, so my 3rd term, this is my 1st term, 2nd term, 3rd term would be 15. So I know that. I'm going to show you another way to get that 15 in the future, okay, instead of having to go through Pascal's triangle every time. And then I have a to a power and negative 3b to a power. So now I need to know what power that is going to be. So if it's the 3rd term, then remember it starts off as a to the 6th is my 1st term, a to the 5th is my 2nd term, a to the 4th is my 3rd term. And then going backwards or realizing that these have to add to 6, which is the faster way, knowing that that's going to be a square. Negative 3 squared is 9. 9 times 15 is 135. So I have 135 a to the 4th b squared. And that is the 3rd term. All right, so this is, we were doing Pascal's triangle every single time to get our coefficients, the 1, 4, 4, 6, 1. We were doing Pascal's triangle, which is fine, but what if it is your exponent's 10, right? Like you don't want to do that. Or if I just say find the 10th term of this and it's to the 26th power, like we got to find some way faster to do this, right? So using that formula that we learned yesterday, the n choose r, formula without writing the triangle, that can give us the coefficient. So if I had an n value of 6, right? So this was to the 6th power, and I wanted the 4th term, right? Because 6, 5, 4, 3 would be the 4th term. It's always one less than that. Then I could use 6, choose 3, right? So to get 6, choose 3, let's go ahead and practice this again to find that coefficient. It would be 6 factorial over 6 minus 3 is 3 factorial, and then just that r value factorial. Simplifying this, 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial. So I'm going to go. And then the other 3 factorial is 3 times 2 times 1, which this is 6. I'm going to cancel out this 6. That's my mental math here, which is 20. So the coefficient on the 4th term of a 6th degree expansion would be 20. All right, 5 choose 1. All right, so that's 5 factorial divided by 5 minus 1 is 4 factorial, 1 factorial. So that is 5 factorial times 4 times 3 times 2 times 1, right, over 4 factorial, which is 5. Okay, so this is just 5. I don't even know why I'm showing my work for that. That is 5. 7 factorial, or sorry, 7 choose 4 is 7 factorial over 3 factorial times 4 factorial. So that is, if I get rid of the 4 factorial on this, I'd be left with 7 times 6 times 5 from that, right? I don't want to cross this off already. And then I still have my 3 factorial left, which is 3 times 2 times 1, right? Because I get rid of the 4 factorial off of this. This is a 6, so I can get rid of this 6, and it's 35. All right. This one right here, 10, choose 6. So we're going to do 10 factorial over 10 minus 6, which is 4 factorial, 6 factorial. Oops, I keep doing it to that one. So I'm going to do 10 times 9 times 8 times 7. I'm getting rid of the 6 factorial, right, from the top end, from the numerator and the denominator. And then divided by 4 factorial, which is 4 times 3 times 2 times 1. So let's see what I can do here. 4 times 2 is 8, so I can get rid of an 8 there. And then 3 goes into 9 3 times, so that is 30 times 7, which is 210. Once again, you can use a calculator for this, and let me show you how to do it in your calculator now, okay? So you can use a calculator to get there, but there's nothing wrong with doing some mental math also. All right, so let me show you 2 ways to put this in your calculator. Okay, here's my calculator. All right, so one way to do this right here is to type this. So I could do 10 factorial. So I'm gonna hit 10, and then you hit the math button, which is the 3rd button down on the left. Move over to probability to the right, and the 4th option down is factorial. Divided by, and now both of these are in your denominator, so you have to group them in parentheses to make sure that they do that first. 4 factorial, math, probability, option number 4. 6, math, probability, option number 4. And you get 210, okay? It might have been easier to do it mental math-wise. But then there's another way of doing this also. If you hit the math button and you go over to probability, the 3rd option down, if you didn't notice, is NCR, right? That's what we're doing, NCR. So you can choose that, which is option number 3. Oops, clear. So option number 3 there. So I'm gonna go to, oh, I know why, because on this calculator, I have to type the 10 first. So I'm gonna type 10, and then I'm gonna hit the math button. Move over to probability, option number 3. And then, so that's going in for the N, and then for the R, which is 6. Some of you, if you have a newer calculator, it might just let you choose NCR and then type in 10 and 6. So hit enter, and you get 210. I wonder if I can change my calculator on this. I'll discover that later. Okay, all right, so that's 2 ways to do it. Keep that in mind. It's up to you. All right, this says use that formula, all right, to find the first three terms of x plus y to the 9th power. Okay, so find the first three terms. So I don't know what the 9th row of Pascal's triangle looks like. So instead of doing 9 rows of Pascal's triangle, what I can do is say is the first coefficient is 9, choose 0. And then the first term is x to the 9th power. And the second term, or not second term, but my first term x is to the 9th power. My second term y is to the 0 power. All right, so that's the first term. And then I'll simplify that out. Plus, then I can do 9, choose 1. X is now to the 8th power, and y is to the 1st power. And then for my third term, I'm going to do 9, choose 2. X to the 7th power, and y to the 2nd power. And now I just have to clean this up. So 9, choose 0 is 1, right? And if you want to type it in this way, 9, math, probability, move over to it, option number 3, 0, you will see it's 1, okay? X to the 9th, y to the 0, so this is also 1. So 1 times x to the 9th times 1 is just x to the 9th. 9, choose 1 is 9. Once again, I can put that in my calculator. 9, math, oops, clear. 9, math, probability, option number 3, 1 is 9. X to the 8th, y to the 1st, right? And then the last one, 9, choose 2. I can put in my calculator, but you're going to get 36. X to the 7th, y squared. So there's the first three terms of that, just to see the pattern here. Find the first three terms of this. So once again, 25 rows of Pascal's triangle, or actually 26 rows of Pascal's triangle, or doing 25, choose 0, x to the 25th, negative y to the 0, plus 25, choose 1, x to the 24th, y to the 1st, and then 25, choose, what am I at, 2, x to the, what am I at? Oops, I put 4 instead of 24. This is 23, y squared. Now, I really didn't have to say where I'm at after that because I want to show you something if you didn't realize it. This number always matches this exponent. So 1, and this is a 1, 2, and this is a 2. And then you can always get this one because those two have to add to this one. All right, so you could use that pattern. So I could always double check mine. These two match, these two add to this. These two match, these two add to this. These two match, these two add to this. So I know I didn't make a mistake with those numbers at the very least. All right, so let's go ahead and clean this up. 25, choose 0 is 1, x to the 25th, negative y to the 0 is 1, so this is just x to the 25th. Then we have 25, choose 1, which is 25. So plus 25. Oh, this is a negative y. That's going to throw me off. I only put y in there every time. Negative y, negative y. So that's actually negative 25. X to the 24th. Y to the 1st. And then 25, choose 2. 25, math, probability. Come on. Option 4, nope, option 3, choose 2 is 300. So I have plus, because that's going to be a negative y squared, which is positive, 300 x to the 23rd y squared. Okay, next one, find the first three terms of this. So we have 15, choose 0, x to the 15th, 2 to the 0, plus 15, choose 1, x to the 14th, y to the 1st, plus 15, choose 2, and then this is x, this is y, and like, notice these two match, right? So 2 add to 15, 13. Okay, clean this up, and you get x to the 15th, 15. Oh, I put y's instead of 2's. Where did I get y from? That's not 15. So this is a 2, this is 2. 15 times 2, which is 30. X to the 14th, And 15 choose 2 is 15 math. Oops. Option number 3, 2. Oops, I hit a 1, 2. Is 105, and then 105 times 4, because 2 squared, is 420, and it's a -2. So this is a minus. At least I'm figuring out my mistakes as I go. No, it wasn't. It was a +2. I was thinking of the last problem. Where was I? 420 x to the 13th. Oh, what happened there? That's not fun. Okay, I'm just gonna use my calculator off to the side now because that calculator's not working. All right, last few here. It says find the 5th term of this binomial expansion, okay? So that, I only have to find 1 term, which is nice. Remember, it starts off with 0. So it's always 0, 1, 2, 3, 4 would be the 5th term. And then this is 2x, this is -3. Those always match, so that's a 4. They have to add to 14, so that's a 10. All right, so 1 term is like the easiest you could do here. 14 choose 4, I'm gonna put it in my calculator. 14 math probability 3. 14 choose 4 is 1001 times 2 to the 100th power, or sorry, 2 to the 10th power is times 1024 x to the 10th times 81. So I'm going to do times 1001 times 81, and I get this monstrosity of a number, 830,269,44. 83 million, right? X to the 10th. Find the x to the 6th coefficient, okay? So I'm gonna go like this on 3x plus 1 to the 8th power. So it's 8 choose, and then I am gonna figure out what that is in just a second, right? This is 3 to the x. This is 3x, this is 1. So I want it to be a 6th power. Those two have to add to 8, so this is a 2, and then those two always match, so that's a 2. See, that is like a little puzzle. So 8 choose 2, I can put that in my calculator, I get 28. 3 to the 6th power is 729. And then 1 squared is 1. 28 times 729 is 20,412. And it just asks for the coefficient, so I don't need the x to the 6th. Find the middle term of 7x to the -7x minus 2 to the 10th. So this is 7x, this is a -2. So when there is to the 10th power, that means there's 11 terms. So this is an 11. And the middle one is going to be, wait, no, there's 10 terms, right? Yeah, there's 10 terms, my bad. There's 10 terms, 0 through 10, there's 11 terms. So the middle one is the 5th one, right? Yeah. So those two match, which is 5. They add to 10, so that's 5. 10 choose 5 is 252. 7 to the 5th is 16,807. 807. X to the 5th, and then -2 to the 5th power is -32. Multiply those 3 numbers, and you get -135,531,648 x to the 5th. That's the middle term. It didn't ask for coefficient. It asked me for the term. Okay, last one is use the binomial theorem to expand this property here. Or sorry, this property, this trinomial, okay? And we've only done binomial expansion. So what we need to do is we need to turn this into a binomial. So I have to ask myself, how can I turn this into a binomial? Well, if I got rid of this, and if it was just 1 term instead of 2 terms, I could use the binomial theorem, which I can do. I can say let u equal 4x minus 1, use u substitution with binomial expansion and figure it out. So I'm going to change the problem to x squared plus u cubed right? And now I'm going to do binomial expansion on this, and then I'll replace the u once it's expanded with the 4x minus 1. All right, so this is the third row of Pascal's, not the third, this is where n equals 3, so this is 1, 3, 3, 1, right? Yes, 1, 3, 3, 1. So that's 1, oops, that's x squared. And you could use, like say this is 3, choose 0. It does say use binomial theorem, so I should be using 3, choose 0, so I'll actually put that there instead. So 3, choose 0. And then this is x squared to the third power, u to the 0 power, plus 3, choose 1, x squared to the second power, u to the first power, plus 3, choose 2, x squared to the first power, u to the second power, and lastly, 3, choose 3, x squared to the 0 power, u to the third power. All right, so now I want to clean this up, right? This is 1, this is 3, this is 3, this is 1, this is 1, I almost said 0, it's 1, and this is 1. Okay, that's a little bit of help here. So now I have x to the 6th power, all right? And then I have 3 plus 3, x to the 4th, u, plus 3x squared, u squared, plus u cubed. All right, so now what I can do is I can replace all the u's with 4x minus 1. So I have x to the 6th plus 3x to the 4th, replace that with 4x minus 1, plus 3x squared, replace that with 4x minus 1, 20 squared, plus 4x minus 1 cubed. So now I clean this up. This is x to the 6th, distribute that. That is plus 12x to the 5th minus 3x to the 4th. This is a lot of work. I have to expand this, so that is plus 3x squared times, that's 4x, nope, that's 16x squared minus 8x plus 1. And then I can do binomial expansion on this, right? So I can do plus, then I'll just expand that binomial. So that's 3, choose 0, which is 1, times 4x to the 3rd power, negative 1 to the 0 power, plus 3 times 4x to the 2nd power, negative 1 to the 1 power, plus 3 times 4x to the 1st power times negative 1 to the 2nd power, plus 1 times 4x to the 0 power times negative 1 cubed. And then expand that. So from there, you can see how it's done. You combine like terms, multiply it out, combine like terms, and you get your answer. I'm going to go ahead and just write down the answer, and you can check it and see if you got it. X to the 6th plus 12x to the 5th, which we already have. We're good with that. Plus 45x to the 4th plus 40x cubed minus 45x squared plus 12x minus 1. All right, that's it for today.